Now, as mentioned before, we can't use the z-table when we're doing mean problems. And the main problem there, the main reason we can't do it, we should say, is because with mean problems, we tend to have smaller sample size. If we have a smaller sample size, I'm not guaranteed to have a normal distribution. And the z-table relies on us having a normal distribution. So because I have issues with my sample size, a lot of times instead we'll use what's called the t-table or the t-distribution. Now, when I go to use the t-distribution, there's some important information I need to have before I start, and probably the most important thing is I need to know what's called my degrees of freedom. Degrees of freedom, or DF for short, takes a couple different forms. If we are doing a one sample problem, then DF is equal to n minus 1. For two samples, it gets a little bit more confusing. We'll have a separate video to talk about that. After I found degrees of freedom, all I have to do is go ahead and find the degrees of freedom row that goes with that. So, for example, if I had degrees of freedom 12, I would come over to the table and I would find my degree of freedom 12 row right here. And these would be the values that I'm actually looking at. Now you're going to notice that this table doesn't include all possible degrees of freedom. So, for instance, maybe I go ahead and I'm doing a problem and I have degrees of freedom 37. If I have degrees of freedom 37, my issue here is that 37 is not on there. And if 37 is not on there, I need to make a choice about which row I'm going to use. We are always going to round down. That is, anytime it's not on the table, we'll round down. And the reason for this is we're erring on the side of caution. So I would use degrees of freedom 30 here. To tell that we're erring on the side of caution, we can go ahead and look at the table itself. Let's look at, for instance, this 95% confidence at the bottom there. If I come all the way up to the top, in order to have 95% confidence, I'd have to have a t-score of 12.71. That is, I'd have to go 12.71 standard deviations away from the center. That's really far out. Now, if I have degrees of freedom 2, I only have to go 4 out. Degrees of freedom 3, I have to go 3 out. Degrees of freedom 4, I've got to go 2 out, and so forth. As I trace this down the table here, notice that the t-score necessary to go ahead and get my 95% confidence gets smaller and smaller and smaller. This has to do with what's happening with my distribution. For low degrees of freedom, my distribution has super fat end tails. That is, there is a ton of error here. People are really, really spread out. As my degrees of freedom get a little bit larger, as my sample size gets larger, then what's happening is my distribution is calming down a little bit. That is, my end tails are getting smaller and smaller and smaller. And the cool part about this is the distance I need to travel away from the center to get my percentage gets smaller as well. That is, when this end tail is fat, I have to move all the way out here. When the tail is smaller, there's more data in the center, which means I don't have to move out as far. More data in the center, don't have to move out as far. More data in the center, don't have to move out as far. In fact, if we trace this all the way down here, what I want you to notice is I go from 2 to 1.99 to 1.98 to 1.62 until, ta-da, I get 1.96. That is, my t-distribution reduces its end tails down and down and down and down until once I get a large enough sample size, the t-distribution is exactly normal. So in reality, the last row here of my t-distribution or my t-table is the z-table row, which is kind of nifty. So what this has shown us here is, once again, a little bit about how we use the t-table or what it's telling us.